Welcome everybody. The title, as you can see, of this talk is Real-Time Stream Processing with RxJS. How many of you know what the sound is called that you hear it in here? Any ideas? Morse code, that's a quite obvious guess, but I can correct you. It's called Austrian English, so I'm from Austria, and my English is a bit Austrian English. That's the sound. Let's start with the presentation. I try to give you some good overview and don't stay in front of my slides. About RxJS, you will get the history of it, who invented or explored it, where to use it, how to use it, and then, of course, a live coding session where you can see it in action. So, let's talk about history. To be more specific, let's talk about the history of RxJS or Rx in general. And every history has a timeline, and I will start at the beginning of time. How many of you know when time began? Any good guesses? Dinosaurs. I'm sure there was time before dinosaurs, but
the birth of Jesus.
The birth of Jesus. Very good, very good. Close. It was 1970 in February to be specific, and everything else is a negative number. There was a second very important date in our history, 1991. What was this date?
Beginning of the web.
Beginning of the world or word?
Web.
Of the web. It was the first day where internet was publicly accessible. So also pretty interesting date. And then, very important, 2004, the official committee of Morse Code introduced the add character to the set of Morse Code characters, and since 2004 I'm finally able to Morse code my email address, so I'm very happy of this happening. 2009 Rx was released. It was open sourced by a company called Microsoft. Maybe you know this company. And after this, nothing happened until now, and now we try to Rx all the things. Let me introduce myself. My name is Michael Hladky. I do trainings, consultings, workshops all across the globe. My topics are RxJS, state management, and of course Angular. So if you're interested, contact me online. I'm very happy to help. But now back to the topic. No, not back to the topic. I run a meetup in Vienna. It's called Angular Vienna. And if you're in Vienna, you could join it. I'm sure you will have a lot of fun there. Now back to the topic. Who explored Rx, Reactive Extensions? And I picked the word explored on purpose because you cannot invent something, you can only explore something, right? So who explored it? The guy was called Meijer. Meijer worked back then at Microsoft, and he has a lot of good skills. Let me point out some of his skills. First of all, he's a brilliant teacher. He's very, very sharp-minded. He has a lot of good know-how in programming. My favorite skill of Eric is he always wears these colorful t-shirts. So whenever you see him, you will see him in one of those t-shirts, and you will not find a single picture or anything of him online without a crazy t-shirt. So this is, I guess, the most important part you should know about Eric. And he has a lot of crazy, funny hobbies. And the hobbies of Eric were the idea that led to this great concept or pattern of reactive extensions. So what were his funny hobbies? And what is the recipe of this great idea? How many of you know Raven tests? Hands up. Some of you, so 4. How many of you ever did an IQ test? More hands. So you know Raven tests. I'm pretty sure in your IQ test you had to fill out a Raven test. What is a Raven test? A Raven test checks your skill of looking for commonalities in patterns. You have two completed patterns here and one incomplete pattern, and the goal of this game is to find the missing piece. And if you are able to realize like the system behind it or the pattern, the commonality of those two patterns, then you are able to solve the third pattern here. And Eric played this just for fun, so he was not testing him all the time. He was playing it just for fun. And if you do something just for fun, I'm not sure if you realized it already, you will learn 10 times more than if you are forced to learn something, right? So as he did it just for fun, he gained a very good knowledge or skill in looking for commonalities in patterns. It's a very abstract skill. What was his second funny hobby? Reading programming manuals. And Eric, like you would read the newspaper in the morning when you have your breakfast or somewhere else, Eric read programming manuals. Everything about other programming languages, their patterns, their internals, or approaches from object-oriented functional spaghetti code. He did really everything possible to get more knowledge, and he also did it just for fun. And those two hobbies of Eric in combination led to this great idea of RX, Reactive Extensions. Back then it was called RE, but after they open sourced it in 2009 in a language that was called C#, still an existing language, they renamed it to RX. Okay, so whenever I try to speak about RX, I call it RX is the missing link in collections. And I will tell you why I believe that, or why I believe the naming missing link in collections is a very good way to explain it. Let's talk about collections in general. And we have push-based collections and pull-based collections. Can somebody name me an example in JavaScript for pull-based collections? Any idea? What? Array. An array is a very good example for a pull-based collection. What are the conditions or the things that we know about the pull-based collection? We know every single item because it's already in our memory. We control when the next item arrives because we pull out item by item with a for each loop or however you would do it. And they are, like, as I said, already here. So we know the size of the array, the number of items, and when the next item will arrive. What about push-based collection? How many of you can name a good example for an item of a push-based collection?
Subject.
A what?
Subject.
What is a subject?
Like subject in RxJS.
True, but before we talk about RxJS, let's talk about general items in the push-based collection. What?
Stack.
Yes, I know where you're thinking about. It's definitely the right direction. But I think about something really simple.
Object.
A mouse click. A key down event. Any DOM event that happens is an item of a push-based collection. When you resize your window, you have resize events that are pushed to you. HTTP requests, WebSocket messages, everything that happens asynchronously, and you don't know when it will happen, and you don't know when the next item will get pushed to you, is a push-based collection. So what do we know about push-based collections? Compared to pull-based collections, they are not in memory yet. We don't know when the next item will arrive, and more interestingly, we don't know how many items will arrive.
Like the future.
It's the future. Okay, so when we work with pool-based collections, we are used to work with something that I call standard operators. Map, filter, reduce, these array first class functions built into JavaScript are very convenient to use, and it's very easy to work with arrays with these standard operators and map and filter or lists. How many of you are used to work with standard operators in JavaScript? Hands up. Nearly half of you. Pretty good. When we work with push-based collections, we have to deal with other problems, and to solve those problems, we most of the time use a set of extra options to help us. In C#, this set of extra options is called PFX, a helper library. In JavaScript, we have other helper libraries that deal with push-based collection problems like asynchrony, race conditions, all this stuff that happens when we run asynchronous code. And Eric looked at this picture here and spotted the missing link in collections. Can you already see where it is? Ba-ba. Here is the missing link in collections. What is the missing link in collections? He introduced standard operators into push-based collections. And the second step that he did was he introduced this set of extra options to the pull-based side. And if you now look at this pattern, you see that we have a unified interface for pull and push-based collections. That's like the main idea behind Rx, a unified interface for pull and push-based collections. And Eric came to this conclusion because he was trained in looking for commonalities, and he had a lot of know-how in programming languages. I talked about infinite number of items in push-based collections. How many of you, for example, know the reduce function in vanilla JavaScript? So, we have a number of limited items, and therefore we can reduce them to a sum, for example. How would you deal with an infinite number of items and a reduce function? Interesting, right? So there was a trick that Eric used to implement working with pool-based collections and these standard operators. I call it the trick with infinite collections. So let's start to think about something really simple that we use to work with arrays. I have an array of numbers from 1 to 5. And I have two operators, a map operator and a filter operator. The map operator maps every item by 2, multiplies every item by 2, and the filter operator filters out all the items that are smaller than 7. And if I do this and we look at the arrows, we see that we prioritize operators. We start with the first operator, pass item by item to the operator, and after we are done, we have a new instance, a new array, that we return, hand over to our second operator, and the second operator performs again his logic on the set of items and moves every item by item through the whole list. And when it is done, it returns a new instance of this array. Now let's take a look about the same example, but now we use observables. So instead of an array of numbers, we have an observable of numbers from 1 to 5. The code here in the middle is exactly the same, identical to the code before. I have a map operation, I multiply every item by 2. I have a filter operation, I filter out all the items that are smaller than 7. And then I log my result. If we now take a look at the arrows, we see a big difference. We see that direction is different. Let me switch back and forth. So what we see is we prioritize items over operations, items over operators. What we do here is we take the first item, we pass it to the first operator, and when we receive the result, we take the result and forward it to the next operator. And after we are done with all operators, we can move on with the next item. So the direction is different, and with the switch of direction, we are able to process an infinite number of items. And this is a trick that he implemented in the core of all those Rx implementations in the different languages. So where can I use it? Because I said different languages. There are a bunch of libraries out there for all the different languages, and this is an incomplete list. And for all those languages, they implemented this pattern that Eric came up with. And what I believe is really interesting here, if I look at this slide, is think about these standard operators with arrays and working with lists, map, filter, reduce. They are implemented in nearly every single programming language, natively, like built into the language. And if you already realized the combination or this pattern that Eric came up with is like super powerful and helps us a lot when we try to compose asynchronous events. As you know, maybe know, working with asynchronous code is not easy. It's like one of the hardest things that you can do in the front end. And it's very, very powerful. You also have to deal with it in the back end, and this pattern solves problems for all the different scenarios where you can use it, front and back end. And no other language, or not a lot of other languages, have this feature built in. So what I want to stress here is that it was really a brilliant idea that he came up with. Where can I use it? And let's get a little bit more technical. I can use it in the front end as well as in the back end. I can use it on the client side as well as on the server side. Let's start with the client side. Eric said back then, we need a helper library that we can deal with event-driven computation, and this is everything coming from our user interface. If you are in the web, this is coming from our DOM, resizing, DOM events, key downs, everything that we can derive from the user interface. And then we have a lot of things that I call asynchronous computation, and these are all our HTTP requests, WebSockets, and all the other stuff that we need to combine with user interaction to have like a really good experience. But you can also use it on the back end. A quick side information for you. How many of you know this server here? It's a very famous server. You just raised your hand. You don't know it, so you don't know it, but you raise your hand. It's interesting what you do. I have to keep that in mind for my next attending a talk. So this is Google's first production server. We made our search queries on this machine. I cannot imagine using such a machine today. But okay, we can use Rx also in the backend to handle many different interactions with other clients or other parts of the cloud. There is one thing that you should be aware if you learn about Rx, and these are marble diagrams. What are marble diagrams? So as Rx helps us to compose asynchronous processes over time, marble diagrams are here to help us to get a better clue of what's happening at the moment, because processes over time are not that easy to grasp and to process in our brain. So we use marble diagrams to visualize those processes over time. This is a quick dummy image that you can see how it could look like. And I will introduce you to all the building blocks very quickly that you can get a clue of those diagrams. So you have a set of components, building blocks for the diagrams, and we use those components to compose together a marble diagram. We have time going from left to right. We can specify a certain duration in time, and this is this dashed block here. We can display an observable, this is this small dash. We can have a subscription. A subscription basically initializes an observable, going always from the consumer side to the producer side. Then we have this observable that is started by the subscription, so we really have the process in time, not the arrow going from left to right with a solid line. And then we have notifications over time that arrive, and they can have a certain shape to display their content type. They have a color to show to which observable they belong to, and they can also contain content like a number or other shapes, and so on and so forth. And then we have an operator. An operator is basically the thing that we use to perform our transformations, filter processes, and so on. And every operator, as well as every function, has a scope, a function scope, or here an operator scope. This is the black line. And inside of this black line, all the internal logic happens. Then we have the operation, transforming a value from A to B, for example. And then we have some functionality that happens inside an event in time that is executed. In this case, my event in time is a function that is executed that maps a value from A to B. We can have a completion event. This symbolizes the end of an observable. And we can have an error event. This symbolizes the end of the error of an observable. And in both cases, this observable, this process in time ends. If the process doesn't end on its own, we can also end the process. We cannot really end the process, but we can unsubscribe from the process. We can say, whatever happens, I'm not interested anymore, and I unsubscribe. I will not receive any other notification from this observable. Okay, as the talk is about Morse coding, I will start to give you a quick intro into Morse code.
Where's the at sign?
What?
Where's the at sign?
The at sign is not here. I'm very sorry to disappoint you, but it's an old picture. It's older than 2004. Unfortunately, I'm sorry. Okay, Morse code 101. Are you ready? Sababa. Okay. Who invented Morse code? Morse code was invented by a guy that is called Samuel F.B. Morse. As you can see, this handsome guy was also the inventor of the telegraph. And Morse code is named by this guy here. You can look it up in Wikipedia if you want more information. What is Morse code? Morse code is a code that helps us to display letters and numbers over dots and dashes. And this is a really creative way of displaying Morse code, as I know that we are all IT people and we need more technical information. I thought about explaining Morse code with a binary tree. A binary tree that has a left branch of a dot and a right branch of a dash. And I guess now it is a little bit more clear for us how we can end up with dots and dashes on a certain letter. Okay. What is Morse code? Morse code is using a keyboard, producing a message and sending it to a screen. As you can see, back then the screens looked a little bit different than today, but they fulfilled the same purpose. On the left side we see the keyboard, and this is maybe a new information for you, because the stuff that you have on your laptop here, how you would call it?
What do you mean?
What do you have on your laptop with all the
Keyboard?
numbers?
Keys?
Keyboard, yeah, so you have many keys on your keyboard, and it's not called keyboard, it's called keysboard. Here I have only one key, therefore it is called keyboard. So just that you know what you have on your laptop. And we use this keyboard with one single key to produce a message. A message consisting out of dots and dashes, consisting out of short and long signals. Let's talk about the parts of a message. As I said, we have dots and dashes, but there is something even more important in this message, hidden, a secret, invisible, the breaks. I need breaks to distinguish short signals and long signals from each other, and I need long breaks to group signals together, to say those three signals together are a Morse code character. And I used pluses and stars for the symbol of a break, so that I can somehow visualize it. If I would fill the long and short breaks into the message, it would look like this. Okay, so let's get to the quest, or to the live coding session. I showed you what Meijer diagrams are like, these diagrams that show us processes over time. What I will use now is called ASCII Meijer diagrams. Meijer diagrams drawn by ASCII characters. What I do is I try to stick with the age of the technology Morse code, and I made it a little bit more old school. So here we have our old school ASCII Meijer diagram. We have two streams, a start and a stop stream. When I push the button down, I start sending a signal. When I release the button, I stop sending a signal. Goal of the first challenge is to combine those two streams together, subtract the timestamp of the start and the timestamp of the stop button from each other, and getting the milliseconds of breaks and sending signals. And from the milliseconds I can map over a table to dots, dashes, pluses and stars. Does it make sense for you? So I combine those two operators, I get groups of down and up events, I subtract down from up event, and I end up with characters. Some real characters could look like this: dots, dashes, pluses and stars. The second challenge will be, now that I was able to translate my up and down clicks to characters, to group those characters together. Whenever I produce a long break, I want to group the characters together and emit one single set of characters. And then I start buffering again, and I buffer all the other characters until my next long break occurs, and then I emit again all the cached values to see where a symbol starts and ends. And if I did this, I am able to translate my symbol to a real letter. This is how groups of symbols look like. And this is our process of translation. I have the groups here, and then I perform a translate function on it, and this translate function can either be successful and then translate it to an L, for example to a real character or a real letter, or they fail and then I produce an error. The problem with streams is if they complete or error, you cannot restart or resubscribe to them. So we need to find a trick to deal with these errors. And this is the third challenge that we try to solve today. That's it. Thanks for your attention. Thanks a lot. If you have any further questions, I'm still around. You can ask me. If you want to make me happy, you can book my workshops and trainings. This is how I pay my salary. And yeah, thanks for your time.